Hello and welcome to my channel. In this math video tutorials, we want to resolve this expression into partial fraction. So let's see the solution to this problem. We have x minus 5 all over x squared minus 9. The denominator we have here is what we call difference of two squares. And of course, this expression can further be written as x minus 5 all over x squared minus 3 squared. So this is difference of two squares, and when you have a difference of two squares, it means you need to take the negative value of that expression and also the positive value. So have x minus 3 into x plus 3. So what we've just done is we were able to resolve this expression into linear factor. Alright, so at this point we need to assign constants to them, and we'll have this expression x minus 3 into x plus 3 to be equals a. You assign a to the first one, x minus 3, plus b to the second, which is x plus 3. So at this point you will need to multiply the whole of this equation by the denominator, which is x minus 3 into x plus 3. So this essentially means that if this cancel out with this, what will be left is x minus 5 equal to, if this cancels out with this particular one, we'll have x plus 3 left multiplied by a. So we have a into x plus 3 plus, if this x plus 3 cancel out with this x plus 3, you have x minus 3 left, and if that multiplies by b, you have b into x minus 3. Alright, now we're able to make the expression look in this linear form. What is the next thing we need to do? We can use by cover-up method, or I usually call it assumption. What do I mean by assumption? You want to assume a value for x such that when you plot it in replacement of x, it will eliminate b, because what you are essentially looking for is a and b, which are the constants. You're looking for the values of a and b. So for you to get the value of a, you will need to eliminate b. Similarly, if you want to get the value of b, you need to eliminate a. Say you want to eliminate b right now. What is that number that you use to replace this x so that the whole of this becomes 0? And then you will be able to find the a. Of course, it's 3. Because if you plot in 3 here, 3 minus 3 is 0, and 0 times b will be 0. But if you plot in that same 3 here, it turns to 6. If you plot in 3 here, it turns to minus 2. Alright, so if you plot in 3, we have 3. Anywhere you see x, you replace it with 3. And then we have a into 3 plus 3 plus b into 3 minus 3. Of course, the whole of this we evaluate to give 0. And here will be minus 2. 3 minus 5 will give minus 2. And then 3 plus 3 is 6. 6 times a will be 6a. So now we're looking for a. We have to divide both sides by 6. And if this cancels out, you eventually have your a to be equal to minus 6 goes into 2 goes into itself is 1. And 2 goes into 6 is 3. So we have 1 over 3 to be the answer for a. Now we're looking for b. So you still make this comment when x is equal to, so what is that value that we'll plot in for x so that it turns the whole of this expression to be 0? And that should be minus 3. Because minus 3 plus 3 gives us 0. And minus 3 here, minus 3 gives minus 6. If you plot in minus 3 here, here will turn to minus 8. So here will turn to 0. So now we're looking for b. We have minus 3 minus 5 from the left hand side. This will be equal to a into minus 3 plus 3 plus b into minus 3 minus 3. This will evaluate to give 0. And what's the next thing we need to do? The left hand side here will give minus 8, and this will be equal to minus 3 times minus 3. Sorry, minus 3 minus 3 will give minus 6, and minus 6 multiplies by b, we have minus 6b. We're looking for b, so we have to divide both sides by minus 6, which is the coefficient of b. And if this cancel each other, b will be equal to minus to cancel minus. And if 2 go into 8, that will be 4 times. 2 goes into 6, that will be 3 times. So we have 4 over 3 to be the answer for b. So therefore your a is equal to minus 1 over 3, and b is equal to 4 over 3. So we need to plot these two values in replacement for a and b in the original equation, this position. Alright, so we have, from the left hand side we have x minus 5 over x minus 3 into x plus 3, and the whole of this is equal to a is minus 1 over 3 all over x minus 3 plus b is 4 over 3 all over x plus 3. Alright, so we're not comfortable with the nature of this fraction, so we want to move this 3 down, so that we have the left hand side remains the way it is, and then the right hand side will turn out to be minus 1 over 3 into x minus 3, and then we have it to be plus 4 over 3 into x plus 3. But of course we shouldn't be comfortable having a negative sign starting an expression. So what we need to do at this point is to use the whole of this, because it has a positive sign, to replace this, and use this to replace this. So we therefore have x minus 5 over x minus 3 into x plus 3 will give us 4 over 3 into x plus 3 minus 1 over 3 into x minus 3. So this is the solution. We are able to resolve this fraction into partial fraction. And one thing I also want you to notice is that the denominator is greater than the numerator, and this is a proper fraction, because if you expand this expression, you notice that you have the highest degree to be 2, and then that is greater than this degree we have up here on the numerator. So this makes it a proper fraction. That's why we just went direct to solve it. So we have to solve more problems in the next video. So if you found this video helpful, please hit the subscribe button, and don't forget to turn on the notification bell, so by the time I upload new video, you get notified. And also like this video if you found it helpful. Thank you.